Welcome to The Explainer. Today, we're going to deconstruct the future of medicine, and we're doing it by taking a deep dive into a single, really influential paper on artificial intelligence. You'll see how this tech, which has roots that go way, way back, is already changing basically everything, from the operating room to mental health care.
So, our guide for this whole explainer is a paper by Pavel Hamet and Johan Tremblay, and their core argument is fascinating. They say that if you really want to understand where AI is going, you first have to understand where it came from. They show us that AI isn't just some recent tech boom, It's really the latest chapter in this ancient human quest to build intelligent machines.
Our journey today is actually going to follow the paper's structure pretty closely. We'll kick things off with AI's surprisingly ancient history, then we'll get into its two main branches in medicine, the virtual and the physical. After that, we're going to face some of the really tough ethical questions before we finally look at the author's big vision for what our AI-powered future could look like.
All right, first up, the authors make this really strong case that to get a handle on AI, you need to look back. I mean, way back, long before we had silicon chips or any kind of code. This desire to build artificial life, it's been with us for a very, very long time. The paper flags this moment, 1955, as the official start of AI as a field of study. It's when John McCarthy finally gave it a name and, a mission statement. But what the authors really want us to see is that even though the term artificial intelligence is pretty modern, the idea behind it is absolutely ancient.
This timeline really puts it all into perspective, doesn't it? The authors are showing us that the dream of AI didn't just pop up in Silicon Valley. No way. It was alive and kicking in the incredible mechanical creations of 3rd century China and in Leonardo da Vinci's workshops during the Renaissance, centuries before it got its official name in the 1950s.
And here's where it gets really cool. The paper draws a straight line from a sketchbook from the 1400s to a 21st century operating room. Da Vinci's idea for a mechanical knight, which came from his obsessive study of human anatomy, wasn't just some flight of fancy. It was, in a very real way, the great-great-grandfather of the precision robotic arms that surgeons use every single day.
Okay, so how do we wrap our heads around all this stuff? Well, the authors give us a really helpful framework. They basically split the entire field of medical AI into two big categories: the virtual branch, which is like the brain, and the physical branch, which is the body.
Let's start with the brain of it all, the virtual branch. This is where you get this powerful mix of raw data and complex algorithms coming together to create a completely new kind of medical intelligence.
The authors point to these three as the core engines of this virtual brain. So think of unsupervised learning like a detective, just sifting through mountains of data looking for hidden patterns with no real clues to start with. Supervised learning, on the other hand, is like a med student who's memorized millions of flashcards of past cases to learn how to predict what's going to happen next. And reinforcement learning, that's kind of like training a dog. It learns through trial and error, getting rewards for good decisions, which helps it figure out the best strategy over time.
But of course, all those smart algorithms are totally useless without good data. The authors make a huge point about this. One of the biggest roadblocks is just how messy and siloed our medical records are. This diagram here shows the dream scenario, a smooth pipeline that takes all that messy, raw data and turns it into secure, organized information that a doctor can actually use to save someone's life.
And this virtual branch isn't just about crunching numbers. The paper points to this really amazing application, softbots. These are basically therapeutic avatars, and they can interact with patients, helping kids manage pain or offering mental health support that's easy to access. It just goes to show how this virtual brain can actually connect with us in a surprisingly human way.
Okay, so let's flip over to the other side of the coin, the physical branch. This is where AI actually gets a body, where it becomes a tangible machine or robot that can interact with the world, and with us.
The real-world applications the paper talks about are just incredible. You've got surgical robots making operations more precise than ever, care bots that help the elderly with daily tasks and even keep them company, and social robots that are showing a wild ability to connect with and teach autistic kids.
I know, this sounds like it's straight out of science fiction, but the paper explains that this is real research being done right now. Just imagine tiny, microscopic robots carrying medicine, guided by magnets, and then by a special kind of bacteria that naturally hunts for the low oxygen spots inside tumors. It's this mind-blowing combination of engineering and biology.
But the authors are really clear that this isn't just some simple, happy story of progress. They emphasize that with all this power comes a ton of complexity, and they make us look right at the serious ethical and psychological hurdles that are in our way. And they don't pull any punches either.
By including this really blunt warning from Stephen Hawking, they're framing the whole conversation. They're saying, look, this technology is a huge deal, and we have to be willing to talk about its most profound and, yeah, even its scariest possibilities.
The paper also brings up a more subtle but just as important challenge, the uncanny valley. You know that creepy feeling you get when a robot looks almost human, but something's just off? The authors argue that for things like CareBots to ever really work, we have to get past that feeling. It's not just about the tech, it's about psychology and trust.
And this is really the core question the paper builds towards. It's not about if we should use AI, it's about how. How do we build a system that gets us all the amazing benefits while protecting us from the very real dangers? So, where do we go from here? Well, the authors don't just leave us hanging with a bunch of warnings. In their conclusion, they actually lay out a kind of roadmap for how we can build a responsible, AI-powered future in medicine.
You know what, the main takeaway here is that AI in medicine can't be some mysterious black box. The authors are calling for a future built on being open and having proof. That means we need clear ethical rules, we need ways to measure if these tools actually work, we need to make them open source so they're accessible to everyone, and we have to demand solid evidence that they actually make patients' lives better.
Ultimately, the paper leaves us with this powerful idea. The path of AI in medicine isn't just going to be decided by a few engineers. It's a huge societal conversation that we all need to be a part of. A conversation about our values, our fears, and our hopes for what healthcare should be. The technology's here, and it's moving incredibly fast. So shaping it for the better, that's on all of us.